In this video I explain how we use the idea of congruent triangles. Uses are all based around this idea. Once we know two triangles are congruent, we know that all pairs of corresponding elements are equal. There are 6 pairs, aren't there? 3 pairs of corresponding sides, 3 pairs of corresponding angles. So let's look at a simple example. Here we have two triangles and we're asked to find angle x in this one. Well, looking at the triangles, we can show that they're congruent. There's a 2 here, corresponds to a 2 here, a 4 here with a 4 there, and the 80 degrees with the 80 degrees. And the 80 degrees is between these two sides, the 2 and the 4 in both triangle. So the two triangles are congruent, SAS, side, angle between the two sides, corresponding sides, and the 4. So, since we know they're congruent, we know that all corresponding sides and angles are equal. And clearly, this angle corresponds to this one, and therefore must have the value of 20. They're in corresponding positions. That's a very simple use. Another use is here. We've learned that with isosceles triangles, that the base angles are equal. Now you've discovered that by experience, but here's a proof of it. We can divide this isosceles triangle into two triangles by drawing a line from A perpendicular to the base. Let's show it's perpendicular, showing the perpendicular signs. And now we've created two triangles. Let's label this point here M, so we can talk about the two triangles. Now there are two triangles. AMB and AMC. Now, angle AMB and angle AMC are 90. We constructed this line such that they were. So that's one corresponding pair in both those triangles. Secondly, AB is equal to AC. That's given because it's an isosceles triangle. In other words, the hypotenuse of the two smaller triangles are equal, and AM is common to both, so it's the shorter side in these two right angled triangles is equal, and therefore these two triangles are congruent right angle hypotenuse side, right angle hypotenuse and side. Now because they're congruent, corresponding angles and sides are equal, and therefore this angle must be equal to this one because they're the corresponding angles in the two triangles. Angle ABM is equal to angle ACM, and we proved what we wanted to. In other words, the base angles of an isosceles triangle are equal. There's a use of congruent triangles in a proof. Here's another proof. This one I'll just talk you through it, but we've learned about property of a rhombus is that the diagonals are at 90 degrees to each other. The angle between these two diagonals is 90 degrees. Again, you've learnt that by experience, but here's a proof. If you compare triangle ABM with triangle ADM, then angle ABM is equal to angle ADM. Base angles of an isosceles triangle that we've just shown are equal in the last slide. AB is equal to AD. AB is equal to AD, yes, because it's a rhombus and all sides are equal. And BM is equal to DM. A property of parallelograms is that each diagonal cuts in half or bisects the other diagonal. So M is the midpoint of BD, or this length is equal to this length. And then we have it, the triangles are congruent. S, on pair of corresponding sides, A, these angles, and S, these corresponding sides. And therefore the triangles are congruent, and therefore corresponding angles are equal. Therefore these two angles are equal, and if they're on a straight line they must be equal to 180, so each of them must be equal to 90, which is what we wanted to prove.